Jai Shri Gurudev. In this video, we'll be understanding the experiment related to realization of binary to gray code converter. It's a logical circuit that is used to convert the binary code into its equivalent gray code by putting the MSB of 1 below the axis and LSB of 1 above the axis and reflecting the n-1 bit code above the axis after 2n-1 row. So let's see in the next slide all about how do we convert binary to gray and how do we verify this. So let's see the design part. So here let us take an example of a binary code which is 0101 and let us see what is its equivalent gray code. Now how do we convert? As discussed above, MSB is taken as it is and the subsequent are being shifted towards right. Let me give you an example here. So 0 comes below 1 and when we add these two we get the answer as 1. So similarly 1 subsequently will be shifted towards right. So 0 plus 1 will have again 1. So subsequently the 0 is again shifted down. So 1 plus 0 we get as 1. So the binary equivalent gray code is 0, 1, 111. Let's take one more example. So the binary code 0, 1, 111, what is its equivalent gray code? The procedure is same, MSB is taken as it is and all the other codes are shifted one towards the right. So we'll have 0, 1 plus 0 we get 1 and this 1 again is shifted by 1 register. So 1 plus 1 we get 0, 1. So we neglect the carry, write down only the value 0. This one again comes towards right side as it's shifted by 1 register. So 1 plus 1 we again have this as 0, 1 which is carry over is again neglected. So the equivalent gray code is 0100 for the binary code 0111. So if you realize this, it's an XOR of the two. So for example, the MSB is B3 and its output is G3. So B3 and G3 it follows each other. Thus you can see B3 followed by G3. Whatever is your input B3, your output G3 is same. Similarly, for the first example, just beside MSB you have 1 which is nothing but B2 and then so XOR of 1 and 0, if you see it is 1. So if you see 0 and 1, your output is always, the gray code is always an XOR of the two variables. So thus you can represent them as shown in this circuit. Let us see the circuit connection. So we can refer the video with respect to experiment number 1 to analyze how the kit works, which all are the input port, which all are the output port, and how do we connect for a 16 pin IC and 14 pin IC. So let's see how do we make the connections. So these are for 16 pin IC and we have 14 pin IC. So we use just for the purpose of understanding, I've used the second one. You can also use the first one if you connect them correctly. So these are the input ports B3, B2, B1 and B0 and these are the output ports which are respectively G3, G2, G1 and G0, the gray codes. So let us do connections. The first one as shown in the pin diagram, 7 is connected to ground, 14 is connected to VCC and then if you can see B3 is connected to 1 and G3. In the diagram you can see B3 is connected to 1 of your IC and then G3 to your output. And here B2 is connected to 2 and 4. If you can see B2 input is connected to pin number 2 and pin number 4. The same is executed here also. Likewise, B1 is connected to pin number 5 and pin number 10. And B0 is connected to pin number 9. So likewise, all other pins are connected as per the pin diagram. And now let us verify it. So let's verify the truth table for binary to gray. So here we have connected the IC7486. The IC is being connected. So these are our input ports, 4 input ports, and these are the 4 output ports. So we are giving input as binary and getting the equivalent gray code for those. So let us verify by switching on the kit. The first row, the input is 000, the output is also 000. Second row, the input is 001, thus the output is 0, 000 and 1. Third row, it is 0010 and the output is 0011. Fourth row, the input is 0011 and the output is 0010. And then now let us see the 8th row, the input is 0111 and the output is 0100. And then the 11th row, the input is 1010 and the output is all 4 ones. Okay, and then let us see the 14th row where the input binary input is 1101 and then the output is 1011. So this is how we can verify the truth table for binary to gray. Thank you for watching the video. Please do subscribe to enhance your knowledge further.